Okay, today we're going to be talking about another standard. This is going to take a little more work on your part and a little more research, but I kind of want to add a little bit to it. It is 8.ESS2, and then we're going to be looking at the particular standard, number 5. This says to construct a scientific explanation using data that explains the gradual process of plate tectonics, accounting for the distribution of fossils on different continents, the occurrence of earthquakes, and continental and ocean floor features, including mountains, volcanoes, faults, and trenches. Okay, a part of this is related to continental drift, that Alfred Wegener had proposed this hypothesis of continental drift, and some of his proof for that, as you might call it, was that the continents fit together, that mountain ranges lined up, and that the coal fields matched, and that they found fern-like plants in Africa, South America, Australia, India, and Antarctica. And also, there were freshwater reptiles found in places that are now separated by oceans. And so, when they ask you to gather evidence, you can look for yourself, and now we have a lot more resources and a lot more technology than Alfred Wegener did, but you can actually look at the map yourself. You can look at the different mountain ranges and see if you can line them up, see if you can find different places where they may kind of add to the validity of continental drift. And I'm not saying you'll prove it for sure, but it's just really to put these into your mind. We're also going to look at the 3 different types of boundaries, because in plate tectonics, it's always at the boundary where changes occur. We had talked earlier about the 3 types of boundaries, and let's look at that slide. Okay, those are the divergent boundary, and these are where 2 plates are moving apart. The convergent boundary, where 2 plates come together, and then a transform boundary, which is where they slide from side to side. Remember, at divergent boundaries, new seafloor is being created, and this happens at the mid-ocean ridge. And then at convergent boundaries, where 2 plates come together, you may have a variety of things that happen. Deep down in the ocean, an old, dense oceanic plate will go under a plate that's not quite as dense or not quite as old. And so that goes underneath, and that's called subduction. And then the transform boundary is where the crust is cracked due to the stress of plate movement, and there can be earthquakes in different places. Now, according to this standard, they want you to research these things, and so that's something that you can do. You can find out where there are earthquakes happening around the earth in a given period of time, and you can actually kind of track those. I think the interesting thing is that there are many times little earthquakes that we never even feel, and they happen a lot more often than you think they might. So I would encourage you to research. You can either even research in our area, because I believe that would be very enlightening to you as to how much plate tectonic movement there is. Now, I'm going to show you a little bit of the reason behind the plates moving, or the plate tectonics, on this following slide. Okay, the convection currents, as we have discussed earlier, were where heat rises, and so that happens in air, it happens in liquids, and it also happens down in the more solid parts of the earth. It's a little molten, so it's not like totally solid, hard things are moving, but they've been heated up to the point that they have more fluidity. They're going to be less dense, therefore they're going to rise, and when they do, they're going to cool off. And when they cool off, they're going to become more dense, and then they're going to sink, and this cycle is going to go around and around. And once again, plate tectonics is the study of plate movement, and that is totally driven by the convection currents. We found that to be true, and so that's why we have earthquakes. If they come together and they poke out of the ground, then the magma comes out, and you're going to have some volcanoes may occur at that point, and there are many different types of volcanoes. One of the things that you can do is to research the volcanoes on your own. You can do just a quick little Google search on those. One of the interesting volcanoes in my lifetime that occurred was Mount St. Helens out in Washington State, and that was a really uh, interesting human interest story. There was a man named Harry Truman. He was an old guy that had lived on the side of that volcano, that big mountain, all of his life, and he had heard it rumble through a lot of his time, and so I would encourage you to research Harry Truman and Mount St. Helens, and you can look at some of the stories. He was on the news quite a bit, and unfortunately, he decided to stay, and that it actually ended his life when the Mount St. Helens did erupt. There had been some warning about it, but even some of the scientists were not far enough away, and they were affected by that particular plate movement that that resulted uh, in quite a change. So Mount St. Helens pictures before and after are quite revealing how the whole top part of that um, volcano had actually blown off of there. So there's a lot of little stories like that. So if you can research some of those, that's going to talk about some volcanoes. Another thing is the Hawaiian Islands. The Hawaiian Islands are just a situation where there is a hot spot in the mantle. And as the plate has moved across, it has poked out of there and created an island. And as the plate continued to move over that hot spot, then another island was created. And it kept going, and then another island. And so there's a whole little string of islands there, of the Hawaiian Islands. Let's see if we can find a picture of that real quick. Okay, just a very quick Google search. I searched the Hawaiian Islands and hotspots, and this popped right up as a video. And you would probably enjoy that as well. But you can see this shows us what I want you to see. This is the line of islands, and this is where the plate, if you can imagine it, has just floated over a hotspot, and then um, that has reached the surface of the ocean, and it just kept building and building and created a big island. As the plate moved on, another island was created, and so forth and so on. So there have been a few of these islands that have resulted from the volcanoes going over that hot spot. So once again, this is a plate tectonic change that that has created a different landform. And so I want you to research and do some research on those different types uh, of plate movements. So there are earthquakes that you can track. There are volcanoes that you can research, some very interesting volcanic eruptions. And then there's these hot spots that have occurred. And then you can also look for just um, any kind of anomaly, what kind of mountain ranges are out there, and see if they connect over on another island or another continent somewhere to see if you can kind of do some research on your own. But either way, that just is going to kind of help you with this particular standard. If you want some more information, you can go back to the 8.ESS2.4 video, and that's a little bit more detailed. Uh, but either way, I want you to enjoy your research, and this will help you with this standard. Thank you very much, and I'll see you a little bit later.